Hi everyone, so now we are going to do one lab. So we are going to do the HSRP. So in this one we are going to use the interface, what we can say, let me check here. I have already the topology, so we can use that one. So see here, this is the lab we are going to do. In this one, let me take this ISP1, ISP2. So if you see here, scenario, I will explain you what we are going to do here. First of all, the basic concept, you know why we are using HSRP, because you need to have the redundancy. And here if you see here what we have the issue, if you assign this IP to this machine, all this machine, they will go this way. But if anything go wrong here, they will not go this way. You need to go to all the computer and change the gateway as this one. To overcome these types of issue, we are assigning this IP. This is a virtual IP. So this device is going to get this IP, whatever device is active. And if anything go wrong to this one, it will move to the other device. You know this one, this concept, right? Before we discuss. So now we are going to do this configuration and we are going to check this output. So here what you have here means this is your company network, small company network. You have one gateway here, R1, another gateway is R2. This is connected to ISP1 and ISP2. I don't know, this name is 6 came, but anyhow we can say ISP6 and ISP7 we have. This is a Google network, we have something here, and we need to send the traffic from here. So what we are going to do, we are going to configure the HSRP. So if you remember, for that one, first basic thing, we need to assign this IP to this interface, this IP to this interface. All that stuff we will do. After that we are going to configure the HSRP here. HSRP is a LAN technology, not the WAN technology, we need to remember. And the configuration, I think I have already ready. So if it is there, we can save the time. So let me check here. Okay, let me check here the configuration. HSRP, I think this one, let's see here. If you see what we are doing here, this is the R1. okay, this is the R1 configuration. First of all, let me take the console and check configuration do we have or we will do. So we don't have any configuration, so I will do here. I taken the ISP1 console, I taken the router R1 console, router R2 console, then I am going to take the router R3 console, and let me power on this machine. We can open all, later we will open. Now I will take only one machine, this one. So concept is important, try to understand the concept. Already theory we discussed in our previous class. Why we need the HSRP? Because the redundancy. We are giving the gateway, and if anything go wrong with the ISP1, it will move to ISP2. Okay, so here the PC, this is the ISP1, ISP6, this is a R1, R2, and this is ISP7 and the PC. So in the PC, this is the router, actually we are using this router as a PC. So if I check here IP interface brief, we have this IP. If I write show IP root, we have the default root. So what I can say, I have this IP 192.168.1.6 to this computer, and he has the gateway towards 1.3. so this is the gateway we are using for this computer, PC1. Actually this is a router, I changed this one as a what we can say the computer we are using as a computer. And this is the ISP1, we don't have any configuration. This is ISP7, we don't have any configuration. In R1, R2 also we don't have any configuration. So first of all I am going to explain you, then we can copy paste the configuration. So if you see, this is a R1. In the R1, what we are going to do, we are going to assign the IP. So first we will change the host name. Already we know that we will go in the privilege mode, from there global configuration mode, then we will change the name of the router, assign the IP. If you see this interface, fast Ethernet 0 by 0, we have 8.8.8.8. okay, so here I put the wrong label. So let me see in the ISP. Okay, all configuration I don't have, so we need to do some basic configuration also. So instead of this one, I will say this should be 8.8.1, like this. So see here what I am writing here. I am writing here enable config t host name. This was R1, and the interface for IP address 8.8.8.1, fast Ethernet 0 by 0, and this interface fast Ethernet 1 by 0 is 192.168.1.1. This is the configuration we done for the R1. And this one, actually, if you want to ping the Google server or anything, we will use this one. But now I am not connecting to the cloud. We are saying this is the ISP, so we can ping this one only. Or if I have another notepad, let me check. We open the notepad 2, notepad 1. What I have, let me check here. Similar thing, so let's do the 2 only. So here, this one, in the real scenario, no need to worry about this one. Why we are keeping this is one to solve the DNS, to look the DNS. This one we are doing. The main configuration of HSRP will start from here. We will do this configuration under the interface which is connecting to our LAN side. So if you see fast Ethernet 1 by 0 in this one, because this is connecting to our LAN, so I will go under this interface and I am going to do the configuration. So this is an interface. I will go under this interface. I am going to do the configuration. If you remember, we will write standby and we will define the group. I am using group 1 and the IP. Whatever virtual IP we plan to use, that IP you will put here. So this is IP I put here. If you want to define the group name, you can define same command. We will use name and the group name. And I need to enable some authentication here, like some username, password. Then same command standby 1 and authentication. We are using MD5 key string, and this is a password we will give. So we are putting the password to this one. So new guy cannot join our group. So this is authentication, and here standby 1 primed. So we are enabling the primed. If you remember, before we told if we enable the primed, they are going to compare the priority and the interface, all the stuff. So for that purpose we enable here, and by default they have the priority as 100. We will increase the priority from 100 to 110. So I say standby 1 priority 110. So now they have the priority as 110. And this side, if this interface go down or anything which is connecting from the ISP, so we need to track this one. So what I will say, before we are saying if this interface go down, the traffic will move like this. But because they are tracking, they are sending the hello messages, they will track this here. Sorry. But the here, if this link go down, no one is tracking. So we can track also that one. How we can track means this one. You can write standby 1 track, and which interface you want to track? You want to track this interface which is connecting to the ISP. So you will write fast Ethernet 0 by 0. You are saying if this interface go down, reduce the priority to 20. So this is 110. When you say reduce, it will become 90, right? So it will become 90. When it become 90 and it is having 100 and the preemption is enabled, so automatically this will become as a standby and this will become active. That's why we do this way. Before lab which we done, we are not doing the track command here. We are not tracking. If anything go wrong this side, automatically they will detect and it will go this way. But if nothing is going here, no problem here. But here you have any issue, no one is tracking. So now I am using the track command to track that one. This one. And I am saying reduce the priority 20. You can give whatever number you want, because here I am using 110, here 20, so this will become 90. And if this become 90 and other side you have the default one is 100, so automatically this guy will take over. And here what configuration we will do? Same thing. Here we will say the config t enable config t R2. This is a basic thing. We will put this configuration, we will assign this IP, and then what we are doing, we will go under this interface and we will write same standby group I am using one, and this is the logical IP. Group name is this one. Authentication, this password and this password should be same. If you give the different password, it will not work. And here also you are enabling the preemption, and here you are not defining the priority. By default you have the priority 100, and you are not tracking here because this is the active router all the time. If anything go wrong here, then only it will move to here. If not, this router is responsible for all the traffic. Okay, and what else we can do? The ISP configuration we need to do, and here I need to send the traffic towards the ISP. So here I can create one default route also to do this lab. I will say 0.0.0.0.0, give space 0.0.0.0, forward that all traffic to 8.8.8. I can say like this. Okay, and here also this interface is 2, we are using 8.2. So the same static route I can paste here also. Here also I am saying anything if you want, forward here to ISP. What I am doing, I am saying router R2, if you want to forward anything, forward to this 8.8.8, that is a ISP 7. This is a 6, that is a 7. So this we will add. So let me copy paste this here in the R1 and in the R. First of all, let me paste all this configuration also. We don't have any configuration. I hope this configuration is clear for you till now, right? So I will go to R2, I will paste this here, and then I need to paste this route also because I need to forward all the traffic towards the ISP. So I will put this here also. Now we will go for R2. I will copy this whole thing, I will paste here. We need to check sometime when we are pasting, you will get some error also. Here nothing is coming, everything is good now. And the ISP configuration, in the real scenario we are not doing any ISP configuration, but this is a lab, so we need to do the basic configuration of the ISP. So what I will do here, like ISP 6 configuration I can say, and here I am going to write enable config t host name ISP 6. Okay, I will give ISP 6 interface fast Ethernet 0x0, IP address 8.8.8.8 255.0.0.0, and we will write here no shut. And here actually in the real scenario you will have the NAT pad here. In this router you will have the NAT or pad here, but still we did not cover that topic, so no need to worry. What I will do the reverse routing from the ISP like this, so ISP will send the reply back to you. But in real scenario ISP will not do the reverse routing towards your private IP, but for lab purpose we will do that one. In real scenario you will have here NAT pad. Okay, so that's why I am doing the reverse routing in the ISP. So I will write here 192.168.1.0, give space 255.255.255.0, and then I will write here 8.8.8.1. This is the ISP1 configuration. Let me copy ISP6 configuration. Let me copy and paste in the ISP6. Where is the ISP6 here? So here everything is good. Now I will copy, I will paste here, and we are going to modify as per our requirement. This is ISP7 I can say, and here you have this one, and here okay, this should be 2, because if anyone want to send to this traffic, go to here. Okay, same thing what we done from long time, same concept is repeating here. Now this is ISP7. So everything is good, we done the configuration. Now we can go to the R1. If you see this duplex mismatch we are getting because in the EVNG switch is full duplex, router is half duplex, that's why we are getting this issue. So if you want to fix this one, what you can do, you can go to the interface which is connecting to the switch and make that one as a full duplex. So you can write interface fast Ethernet 1/0, interface fast Ethernet 1/0, where I am. Okay, in the router I will change first of all router which is connecting to the, I am in the R1, so I will write interface 1/0 duplex full. Okay, so now it will not have the error. In the R2 I will put here also interface fast Ethernet 1/0 duplex full. So now you don't have that CDP and the duplex mismatch messages. So now what I will do in the R1, we can check the HSRP is working or not. We can write show standby brief, and you can see here what we are getting here. We are using the group 1. This is a priority we set, and this is the active router. Who is active? Local router. And this is a standby IP, and this is our virtual IP. This is our virtual IP. Now you can save this configuration if you want. Here, save, and then you can, this is our machine, right? So you can ping from this machine, like ping 8.8.8.8. check it is working or not. It is reachable. It is reachable. If you do here trace route 8.8.8, it is reachable. So I am pinging, I am reachable. This is the PC, this guy. This guy is accessing the internet. We are saying 8.8.8 is a internet, and he is accessing which device, via which device? Via R1 device. How I know? Because if I check in the R1, this is the local, and the local is a R1. So R1 is a active, so he should go through R1 only. If you see this interface 192.168.1.1, he is going from this interface. 1.1 means he is going, this PC1 is going now currently this way, like this. Okay, now what I will do, I will make this interface down. When I make this interface down, the priority is 110, it will reduce 20, so it will become 90. Preemption is enabled, so this both guy will compare the priority, and this guy will become as a standby, and this guy will become active. Our traffic will go this way. We can check that also. So what I will do, I will go to R1, and the interface fast Ethernet 0/0, I will make that down. Interface fast Ethernet 0/0, I will write shut. Okay, which interface? This one. So now HSRP active, it is changed from active state to speaking state, and you can check here, do show standby brief. If you see, priority reduce, and this guy become as a standby. Who is active? R2 will become active. And if you ping from this guy, you can check the traffic is moving from different ISP. Before you have 192.168.1.1, you will have 192.168.1.2. They are using virtual IP, but the traffic will go from 1.2. Okay, and if you go here and type here, see, before this guy is standby, now he become active. And you can check also, you can write do show standby brief. So you can see this guy priority is 100 using the group 1. Now he is active. Local is active. Local means this router R2, and this is a standby guy IP, and this is a virtual IP. And if you see here, now the traffic is going from second side. Before it is going from 1.1. Now how it is going, if you see, it is going via this side. Before, traffic is going this side, this way. When I make this down, automatically this priority from 110 to reduce to 90, and here is 100. So they will check who is having high priority, this guy. So this guy will become active, so the traffic will start going from this way. You can check, you can verify with the trace route. So when I write the trace route, this destination Google server, so how it is going? It is going 1.2. 1.2 means this path, not that this path. Okay, so this is a HSRP. We have the logical interface. No need to change this one or that one. Like in old system, we can say we will change this one. We will give as a gateway. If this have any issue, then we will change this IP as a gateway. No need to do anything like that. Just you will give this virtual IP as a gateway. So we have whatever device is active, that device is going to get this virtual IP. If this device go wrong, this device will take this virtual IP. That's all. Okay. So this one we can say HSRP. So we done the HSRP. This is a HSRP lab. Configuration is simple. Everything is good. If you see configuration, let me explain one more time configuration. This one from here to here, you already know we are assigning the IP address to the interface. And this one we can say this is for the resolving the DNS. So now we are not using www.google.com or something here. We are using Google server as 8.8.8, so no need for this one also. Important thing, go under the interface, enable the HSRP. With this command we enable the HSRP. Standby group I am using 1, that's why I wrote here group 1. If you give here group 2, you can give group 2 also. So group 1, and this is a virtual IP, and whatever name you want to give, you can give, and you enable the authentication here, and this is a password. Both the routers should have the same password. And this one I am forwarding all traffic towards the ISP, that's all. And in the ISP I am creating the reverse routing, because actually we did not done the NAT here. In the real scenario you will have the NAT pad here, we don't have that one, that's why I done the reverse routing, so traffic should come back also. Okay, I hope it is clear. This is simple lab what we done HSRP. So